In the previous video, I looked at two fundamental problems that a programmer god has to solve in order to create a physical mass space-time universe within a simulation. The first video showed how to create from the number 1 the units we use to describe our physical universe. And these are the units kilogram, meter, second, and ampere. The second video showed how to store the dimensions of mass, space, and time within mathematical structures. These solutions were predicated upon two assumptions. The first being that although the units for mass, length, time, and charge are independent of each other, clearly mass is not time and charge is not length, there is a mathematical relationship between the units. And this link between them is what the programmer used to create them from the number 1. The second assumption was that mass, length, time, and charge are analogous to our Planck units, and furthermore are themselves geometrical objects, and as such, they can be combined together via that unit relationship to form more complex objects, such as electrons and planets. We see this in the table, the MLTA objects and their unit numbers. This means that an apple has mass because the mass object M forms part of the apple object. The apple is a complex event formed from these MLTA objects combined in a systematic apple-like way, shades of Plato's universal forms. V is the object for velocity. It doesn't represent the speed of light, it is the speed of light. We know the value for this omega, and so we can calculate the value for v. Our speed of light c also has a numerical value and a unit, and so we can convert from object v to c by including scalar v. Because object v is dimensionless, the scalar must also include the unit, such that our c equals object v times scalar v. We can add scalars to our other objects, but because the scalars have units, they follow this unit relationship rule, and this means that we only need two scalars. I've been using scalars r and v for my examples in the previous videos. In summary, we have these geometrical MLTA objects, which are natural units. They are the units used by the universe itself, built into the universe source code. They are dimensionless. We then use scalars to convert from these objects to the system of units we use, which are those SI units. If we meet aliens, they will also be using scalars, which they use to convert to their system of units. The MLTA objects, however, being universal, will be the same for aliens, regardless of which galaxy they come from. First, a disclaimer. According to science, there is no relationship between the units. If there was, our fundamental constants would no longer be fundamental, and we would have to redo our textbooks and a lot more. For example, numerically, the left equation is the same as the right, but the units don't match, so it's just a coincidence. As your high school science teacher taught you, the units have to match or the answer is wrong. However, is it really wrong? If we solve this equation using objects and scalars, then the answer is correct. We can compare objects and scalars using versus textbook values. We are using only 4 numbers, 2, alpha and omega, have fixed values, and the 2 scalars are unit dependent. Yet, we seem to have solved 6 fundamental constants. My science teacher might now be scratching his bald head. We meet aliens, so we propose to combine certain combinations of constants whereby the scalars and units cancel. The aliens chose their scalars to convert from the MLTA objects to their alien system of units, and we chose our scalars to convert to our system of units. However, take away the scalars, and we and the aliens are left with only the MLTA objects. And this could be one way for us to converse with aliens, because we would then have this common language, this language of the universe itself. We don't have alien units to test, but we can derive MLTA equivalents to our constants. We see that numerically they are completely different, and they should be different. They are not using our units of kilograms and meters. My science teacher will tell me that for this reason alone, there cannot be any connection between them. He will also point out that these are fundamental constants and cannot be derived. In this table are listed our textbook values on the left, and we can compare with the MLTA equivalents on the right. Alien constants will give the same values. The least precise results are those using G and KB, and these are not well known anyway. I'll come to this later. The best results are when comparing with the constants that are known by us to a high precision. There are more examples of these anomalies listed on this website. I will give the link below. I am using Wiki as it has a convenient format for mathematics. As noted, in science there is no such unit relationship, and there are no geometrical objects. The physical constants are fundamental and cannot be derived. And so the question then becomes, statistically, can these results be dismissed as mere chance? Or are they evidence that we're in a simulation? Just a note, for textbook values, I'm using CODATA, as it is the accepted reference for those constants. However, in 2019, 4 constants were assigned exact values by some UN committee. In this model, if 2 constants are assigned values, then all other constants are known by default because of this unit relationship. And so you cannot assign values to more than 2 constants. In 2014, there were only 2 constants with exact values, the speed of light and the vacuum of permeability. And the scalars for these 2 constants are R and V. Would the UN have to reconsider? In the next video, I want to return to the electron and what it can tell us about the formula E = mc².